Physics is on tomorrow, so let me just share a few tips, maybe which can help you boost the last hours before the paper. For the love of science, people, for the love. So this is my new parent. Let me just share a few tips with you. Okay, so among the things that get to maybe make some people worry so much, like when they encounter some of the questions in the papers, among the things that are challenging, the first ones are graphs. Okay, graphs. When people encounter graphs, sometimes they become maybe they develop anxiety and worry on how to go about the graphs. We may not really learn how to really do everything about graphs, but some important things you should take note when presenting your graphs or your information in form of a graph are simply: firstly, you have to have the title of the graph, have the title of the graph. Secondly, you have to have the axis drawn, okay, to drawn, therefore the size drawn to good size, and then a good scale, okay, good scale, good size of axis. Therefore, at least the graph should cover 80% of the graph paper, big enough, well stretched. Apart from that, the axis should have well labeled, okay, labeled axis, okay, well labeled axis. If it's velocity against time, let the velocity graph or the velocity axis be well labeled as v, then in brackets the unit in which that velocity is being measured, for example, then the title up there, and even time, then the seconds, and well labeled scale. Okay, apart from that, the plotting, okay, plotting should be done. I usually go or advise mostly to use crosses, like be as accurate as you can, therefore use to mark crosses to simply plot your graph. And then how you draw a graph, whether it's freehand or you're using a ruler, depends whether it's the type of information given. Okay, the type of information given, and sometimes you may be required to draw a best fit line, but basically I think those are some of the important things that a graph should have. And a graph should be plotted in pencil. Okay, should be plotted in pencil. So the next thing that people get to worry much, or maybe the things you should focus on again, apart from graphs, are simply laws. Try to go through the laws. Okay, try to go through the Charles law, the Hooke's of this world, the Faraday. Okay, the Faraday. Apart from that, you can even check out the Avogadro's, okay, Avogadro's law on gases, okay, molar gases. Apart from that, you can even go Newton's laws, okay, Newton's laws, the three laws. Apart from that, check out as many laws as possible, the Lenz's laws, all those things. You have to at least be acquainted with them, the laws. Go through the laws, because right now you cannot start studying a topic that you never understood. So as you polish up, take note of the laws, and then the graphs, okay, like the graph, the decay curves, the interpretation of velocity time graphs, distance time graphs, and all those things. Then lastly, the major thing here that you should be into, like right now, is a practice on how to write formulas. Okay, every calculation in physics almost every calculation involves a formula. So rememorize or try to write down as many formulas as you can from time to time before the paper tomorrow. For example, cost of electricity. Cost is equals to unit times unit price. Okay, cost of electricity is equals to cost is equals to unit times unit price. This formula goes along with units. This is energy, so unit is equals to power times time, where power is in kilowatts. Do not forget that. Then time is in hours. Okay, memorize as many as possible. Velocity of a freely falling object, for example, is v is equals to root 2 gh. That's the velocity of a freely falling object, where g is gravity, h is height. You cannot just write formulas without really knowing where you're getting them from. So for you to write a formula, it's like you're forcing your brain to simply like define whatever you're trying to write, define all the characters in the formula. So it's like another level of studying. After you know the laws, you know the general information about definitions and other things in the formulas. Formula for kinetic energy, for example, is ke half mv squared, or mv squared over 2 can still suffice. Formula for efficiency comes in many ways. Okay, efficiency is equals to mechanical advantage over velocity ratio times 100 for simple machines. Apart from that, you can even say efficiency is equals to output over input times 100. Output of what? This can be power, it can be work, it can be energy. Okay, so it can be power, work, or energy, which can be output. Even down it can be power, power input, work input, or energy input. So efficiency is a little bit general depending on the context that you are being asked of it. So the other one, I would say maybe power is equals to VI. Try to memorize as many of them. Period of a pendulum, for example, is time over number of oscillations. Frequency is opposite of period, where number of oscillation over time taken. The length formula, you have 1 over focal length is equals to U plus 1 over V. Therefore, I can't remember very well if this is distance of objects from lens, then distance of image from lens, but whichever one to still come out correct. But this is the focal length. Okay, formula is like a specific heat capacity of C is equals to energy over mass and change in temperature. This is your specific heat capacity. Okay, so at the end of it all, I try to memorize as many formulas as possible. Where it is equals to mg. Okay, when it comes to radioactivity, you have equations like energy is equals to mass times power, times speed of light squared. E is equals to mc squared. The other one for which comes radioactivity is quantity remaining is equals to original. This is original quantity times half to the power n. Half to the power n, where n is equals to the period of time given over half-life. Therefore, n is the number of half-lives. Okay, so try to write as many formulas as possible. The wave equation, for example, V is equals to a lambda times frequency. Okay, I can go on and try to remember as many formulas as possible. The other formula is a formula for a thermometer which has no scale, but has the upper fixed point, which is 100 degrees, and then the lower fixed point, which is 0 degrees. Okay, you only have the upper and the lower, but anyway, let me just say it has no scale. How do you calculate for the temperature? Okay, by observing the expansion of the liquid. Therefore, you have T, which is the temperature over 100, which is a constant, is equals to LT minus L0 over L100 minus L0. L0 is the length of the column at 0 degrees, length of column at 0 degrees, length of column at temperature T, they are non-temperature, length of column at the upper fixed point. Then L0 is the length of the column at the lower fixed point. Okay, so at the end of it all, you can solve for either T or LT or even any of these variables. So try to memorize as many formulas as possible. Scribble them on the paper and throw away the paper, then write some more. Okay, write some more. Try to think of them as in just grade 10 formulas. For example, mechanical advantage is equals to load over effort, while it's the mechanical advantage, while its velocity ratio is equals to effort distance over load distance. Okay, try to think of them in that way. Try to start from grade 10 and try to climb up higher and higher. Try to think of conversions like 1 decimeter cubic is equals to 1000 cubic centimeters. Okay, and then 1 decimeter, for example, is equals to 1 liter. This is volume, this is capacity. So try to think of these my exchanges, the conversions, the formulas. Try to think of the laws. Okay, definitions of laws. Okay, definition of resistance, definition of current. The formula defines current. Electric energy, for example, electric energy is equals to QV. Okay, this E is actually work. This is also electrical work. Okay, apart from that, charge is equals to IT. Okay, IT, current times time. So think of as many formulas as possible, and then do not forget the units, of course, so that at the end of the your calculations in the paper, you actually have the correct units. So write the formulas and throw away the paper. Write some more, throw away the paper. Solve some questions, go to the laws, go to the graphs, study them, then write the formulas again, throw away the paper, and see how many you accumulate. If you can go up to 40 or so, then you actually be much more simpler. Much more safer.